Hello my dear students, this is Akash SD and welcome to the ASD physics classes. I hope so students you all are doing really great. So students, in this video we are going to solve the question from the chapter Semiconductors, and by seeing the diagram you can see very well this question belongs to the chapter Zener diode. So students, do you know about anything about the Zener diode? Yes or no? Okay, let's learn. So students, the Zener diode is the one special kind of diode that is designed to use in a reverse bias. Why reverse bias? Because in reverse bias it will use as a voltage regulator. Now what is the meaning of the voltage regulator? That means across whatever load this Zener diode will connect, it will supply the constant voltage. Okay, so here you can see the voltage of the Zener diode is how much? 5 volt. That means across the load it will always supply 5 volt. Okay, that is the use as a voltage regulator. I hope so you understood very well. So now let's see the question. In the given circuit, if the power rating of Zener diode is 10 milliwatt, the value of series resistance RS, here this value, to regulate the input unregulated supply is how much? Okay, so students, when you will go through the question, how much is given here? The Zener diode power rating is given here. How much, students? It is given here. You can see very well the 10 milliwatt. Okay, 10 milliwatt. After that, if you will see from here, the Zener voltage how much is given here? You can see very well. It is given here the 5 volt. Okay, in this circuit diagram. So here we have to calculate the value of the RS. So let's first analyze the circuit and let's see what are the things we should do it to solve this question in an easy way. Okay, so what will happen that here, this Zener diode, this supply plus this minus polarity. So what will happen that here, this Zener diode, because of this voltage across the load, how much current will go? IL current will go. Okay, and this Zener diode will let it pass how much current? IZ current. Okay, this is the IL. Now students, after that if I apply here the KCL at this point, so you can tell very well here this IS will be equal to how much is there? I can write here IZ plus IL. Is it this current IS? Now, so this polarity is plus, this polarity is minus, students, and let's take here this voltage is Vs. Now Vs. So here our target is to calculate the RS. So next one, if I write here by KVL. Okay, so students, by KVL in the loop, this left side loop, what can I write here? This Vs is equal to V, this S, and plus this Zener voltage Vz. But here what is the thing is happening that here this is also Vs, this is also Vs, so it is not looking good. Okay, so I can just write here the Vs1. What I have written here, the Vs1, let's take here, because here Vs stands for the supply voltage. No need to write Vs again. So what will happen that here, students, say you can write here very well, this Vs1 will come here what? It will come here Vs minus Vz. Okay, now students, after that if I want to calculate the value of the RS, by Ohm's law we know V equal to IR. So R equal to V by I. What is the voltage I have taken here? Vs1, and the current how much is there? The current is Is. So the complete story will revolve around this. Okay, great. Now students, after that let's make here the equation 1. Now, next one, what will happen that here, to calculate the value of Is, we have to calculate the IL, we have to calculate the IZ and all that. Okay, so if I talk about here the IL how much here? Now this voltage Vz is applied across the load. So IL is given by, students, Vz by RL. Is it? Vz value how much is there? 5 volt, and here 1 kilo ohm. So see here please, 5 and 1. So when you will solve here, this will come here 5 milliampere. Now because kilo ohm will make it a milliampere. After that if I write here this IZ max. Okay, see here this IZ max. IZ max how much it will flow here? Let's see here. This IZ max is given by, students, this PZ max by Vz, because we know P equal to Vi. So I equal to P by V. Is it? So when I will solve here, PZ max how much is given here? See here 10 milliwatt. Is it? So see here 10 milliwatt. Unit have to be very careful. And this Vz value how much is given here? We have seen that here 5 volt. Just put here. So what is coming here? It is coming here the 2 milliampere. How much coming? 2 milliampere. Now we know very well this current is the 5 milliampere and this current is the 2 milliampere. But here have to be very careful. Across the Zener diode or through the Zener diode, the current can vary, but the voltage will be always fixed across the load. Okay, So what I want to tell you students here, if I go for the maximum current, how much? The maximum current across the not across, through the resistance. Okay, so students, this will become here what? This will become here IL plus IZ maximum, correct? IZ maximum, here I have told you very well, see here IZ plus IL. When this IZ is maximum, IS will be also maximum, is it? So students, we can write here this one, no? This one, we are going to see that here, is it? So now we can write here this IL, how much is coming here? 5 milliampere plus this IZ is how much? Maximum 2. So here what will happen that here students, this will come here the 7 milliampere, is it? The maximum current through the resistance RS is the 7 milliampere. Now we will use here this. RS equal to how much? Vs1 by Is. Vs1 how much is there? You know Vs minus Vz. Vs value 8, Vz value 5. That means it will come how much here? 3 volt, is it? So this thing we are going to see here. So hence if I write here this RS resistance, it is given here what? Vs1 by Is. So what will happen that here when this Is is maximum, this resistance RS will be what? Minimum. Okay. And this Vs1 value how much came here? We have seen that 8 minus 5 means 3. And Is max how much here? This is the 7 milliampere. So this will make here what? 3 by 7 kilo ohm. So when you will solve here, it will be 7 4 28, it will come something 0.42 kilo ohm. Okay. The minimum resistance value is how much? 0.42 kilo ohm approximately. Okay. After that, what will happen that here? If we go for the next one, if we go for the next one, students, kindly see this one. Now what will happen that here? If across the Zener diode no current is flowing, then what will happen that here? The total current of the load will pass through this source resistance here. Okay, what I am telling here, see. So what I am telling that here, second situation, students, see here, this is given by Is is equal to IL plus Iz, is it? So if in case this Is is the minimum, this Iz will be also minimum, or we can tell in such a way, if this Iz is minimum, then Is will be also minimum. Okay, so let's put the value here. IL how much is there? 5. And minimum current through the Zener diode how much? If the current is not flowing through the Zener, then what will become here? 0. That means we can write here the 5 milliampere. Okay, so in this situation what will happen that here, if I write here the RS, how much here? Vs1 by Is. Now, if this Is is minimum, okay, then what will happen that here? This Rs will be maximum, correct? So, this value is here 3, that we have done also, and minimum is 5. So, what this will come here? 3 by 5 means 0.6 kilo ohm, okay. So, if we see here both the things, this first one and this is second one. So, we can write here this Rs value should be what we can tell less than or equal to 0.6 kilo ohm. And greater than or equal to, what is this? 0.42 kilo ohm. Okay, so 0.42 kilo ohm minimum and 0.6 kilo ohm is what? Maximum value, is it? So let's see here, the students, kindly see first very well how we have done this, is it? So now after that, if we go for the next one, see here please, which value is coming between 0.42 and 0.6, you can see very well. This 0.5 is coming in between that. So students, when you are keeping this 0.5 kilo ohm here, RS value, then this circuit can operate very properly without any breakdown of the Zener diode or anything and all. Everything will work very properly, students. So kindly see very well. So students, I hope so. This question you have understood very well. Keep studying, keep growing.